So we have seen how merge without a by clause and without a common identifier can lead to a system shutdown also. Okay, so we need to be cautious. Now let us move forward with some basic more syntaxes. I already used rename syntax while trying to show you the merge. So here let's see the rename, and the importance is not of the syntax, but why rename. And probably you would have understood it from the previous example also. When I merge two data frames without specifying the by clause, R intelligently identified cust ID and did a right job. But when I gave a one column had cust ID and second had CID, and when I merged the two, at that time I ended up with a cross join, and it took huge amount of time, and finally it gave an error that it could not allocate sufficient amount of memory for the new object being formed. Yeah, and this is called metadata. Metadata is basically data about data, and one of the principles of metadata is consistent naming convention. What does consistent naming convention mean? Consistent naming convention means that if in one table you are saying a particular column XYZ, in another table same column having the same interpretation should be named as XYZ only. For example, I have got a product master. Product master is a table where details of all the products is stored, and which customer then buys that product. In the customer table or the purchase table, again that reference will come, what product the customer has bought, and again there has to be same column name, product code. In the product master, if you you identify a product by a product code and you say it product underscore code. In the transaction table, the same column should be again named as product underscore code only. It should not be such that while designing your tables, one side you say product underscore code, and in another table you say prod underscore code. That is not a right design principle. Okay, so there has to be a consistent naming convention across your tables. That is point one. Second point is, when you are giving names to your columns, the column name should be self-explanatory. For example, in this data, I have got this column balance. Okay, typically in a banking, assume you are working and then you compute multiple balance fields. You you have one field saying end of day balance. Second field is called average monthly balance. And then there is a third field which is average quarterly balance. Okay. Now you name all these balance field as, when you are doing ETL, extraction, transformation, loading, basically all data manipulation exercise you're doing, and when you designed it, you have called them as BAL1, BAL2, BAL3. BAL1 is EOD balance, BAL2 is monthly balance, and BAL3 is quarterly balance. 6 months down the line, you have to revisit your code, and then you see BAL2. Will you recollect what BAL2 was? If you name them as EOD BAL, AMB BAL, AQB BAL, it would have become self-explanatory. So giving a names to column which is self-explanatory is a very important thing. Similarly, I can give one more example. In banking, typically there are three types of dates. For a given transaction, there are three dates. One is called a transaction date, second is called a posting date, and third is called a value date. I'll explain. Transaction date is when the actual transaction is to happen. For example, salary has to be credited on 1st, but information is uploaded 1 day before. You're doing a posting, but actual transaction happens on the 1st. What is value date? Assume you take a overdraft facility and you have been charged at the time of opening the overdraft. Say overdraft opening account 5,000 rupees. You have been charged. And while opening the overdraft account, you were said there will be no charges for this. You have now been charged minus 5,000. Your account is already gone minus 5,000. Now you complain to them saying that my account was opened and it was said that there will be no charges. But on day one itself, you have charged me opening charges 5,000 rupees, which means you have gone minus 5,000 debit. In an overdraft account, if you exceed the amount, if you withdraw more than what you have in the account, interest is to be paid. So you start paying interest on that 5,000. Technically, that interest you should not be paying. And this problem gets resolved 1 year down the line. So the reversal will happen 1 year down the line. That is transaction date. But effectively, when the reversal should have happened? That date. That is value date. So the transaction will be shown today, but there will be another field saying effective value date, it should have been 1 year back. So this is why value date is there. Getting the concept? So transaction, posting, value date. Now assume again the person who designed this system would have called it as date 1, date 2, date 3. All users of the system in the bank, they would have gone crazy. And they would have each new person coming into the organization, if they use it, they would say, hey, date 1 means transaction date, date 2 means posting date, date 3 means value date. Each person coming, you have to keep explaining it. And despite explaining one of other, you will keep forgetting. That's why giving appropriate name is very important. And one of the reason why many people do not rename the columns is they feel they don't know the syntax. Actually, syntax is not important. Important is our intent of doing the right job. That is more important. If you feel that no, giving a self-explanatory name is very important, you will go on internet, within 2 minutes you will find the syntax. So again I repeat, syntax is not important. Logic and objective is more important. And now as you learn, because now you're already in the 4th session of this, gradually now you have to move out of syntax. You have to start thinking concept. Concept is more important. Why appropriate naming is to be done? Why merging? What is the importance of merging? When to merge? Why to sort? All these things, concepts are more important. Once you know the concept, you have to do a logical way of using it, and then finally you have to find the syntax. Okay. So let's see a syntax of renaming. For example, score, SCR, it is self-explanatory. And one of the way of abbreviating the column names, if you want to abbreviate column names at any given point of time, vowels have to be removed. The way to abbreviate is remove the vowels. Okay, so score, SCR and SCORE. But let's, for the sake of having a syntax, let's see how to rename. So I've got these column names. We have already done CID thing. Let me type here. So let us get all the column names first. LR underscore DF. These are my column names. And now I want to rename it. So the syntax is simple. Call names LR underscore DF. Now score is in which position? Cash occupation is 6th. Number of credit is 7th. This is 8th. This is 9th. So I'll say 9 is equal to score. And my column is renamed. Now if I again check the column names, it has become score. So just try it out.
So instead of 9, we can put SCR.
I'll show that syntax also. Just try this syntax. Here, when we renamed it, I knew that score is at 9th position and I used that. Just in case I don't know the position, then you have to identify the index through some programming way. So here, what you have to do, you have to use this kind of a syntax where I am now comparing a given column which I want to rename with all the column names. When I use this syntax, for that column, the value will become true, and for all of them it will become false. If you just type this part of the syntax, you can use call names also here. Names and call names are same. Both of them returns the column names. So let's just type this part of the syntax and see what it returns. It will return a vector of true and false. Okay, only one value will be true where there is a matching column names. So let's just type this much part. Names LR underscore DF. Names will return all the column names, a vector of column names, and I'm doing double equal to, and because we have already changed SCR to score, now I'm going to compare as score. If you run this, you will see this is a vector false, 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 and one true and then false. Okay. Now this part I can now put it here. This part I can now put it here and now rename it back to SCR just to see whether the column is now getting changed. So and then again run this call names and you see we got SCR back. So that this part of the code, I've now, instead of putting hard coding 9, I've now put this instead of 9. The comparison logic. Yeah. There are other ways because R provides you multiple packages and multiple ways of renaming. I'm not going to go and cover up those. We'll move to the next slide. Now the next question is changing data types. See here, no, see here what has happened is like this is where I know the position, but many a times we will not know and you want to do it programmatically. In that case, this kind of a logic is better. So this is all dynamic programming. When you go, we typically avoid hard coding. Yeah. For example, this same exercise you have to do across say 5 tables. Okay, 5 data frames you have to do. One way is you go in each and every data frame and type the syntax. Other thing is you just copy the syntax, change the data frame name and run it. Otherwise you will have to manually see in which data frame this column is occurring at which position. So programmatically what happens, these things become faster.
So instead of looking for
Yes. So now let us see basically what is called converting variable types. Technically it is called casting. Casting means converting objects from one type to another, converting data type from one data type to another. That is called casting. Yeah. So before we do casting, let us see the structure of our data frame. So to get the structure, the command is very simple. Str equivalent of this, if anyone has worked on Oracle, equivalent of this is describe. When you use a describe and table name, the entire structure of that table comes into it gets displayed. And equivalent in SAS is proc contents. Proc contents is a syntax. So each tool always provide these functionality is the point I'm trying to drive. So here when I see this, here my cust ID is factor. I do not want cust ID as factor. Okay. I want that cust ID should be character. Reason we all know why we want cust ID as factor. So let us simply do lr underscore df dollar cust ID equal to as dot character. As dot provides you many functions. There are different types of function. As dot character, probably as dot numeric, as dot date, okay, as dot integer. So these are all casting function. Here my objective is character, so I'll say as dot character. And which column I am wanting to convert the data type? Cust ID. So I'll have to again put the same thing here. Okay. The output of this will go and the same column name is what I'm assigning. So when I run this, now if I again see the structure, or I can specifically see the class of that column, df dollar cust ID, now it has come character. Yes, this is called casting. Sorry. Okay. Now let us see this target column. Target is integer. Okay. I am going to do certain steps to show that if integer values are stored in a factor, we should not directly cast a factor to integer. We'll just see that. So as a factor, assume what I'll do is I'll create a new column target 2 because I don't want to corrupt the data. What I'm doing is as dot factor dollar target. Whatever is the target value, I am now putting it into a new column target 2 and storing it. Okay. Let us view this data. Everything is okay. 0, 1. This is 0. This is 0. This is 1. This is 1. This is 0. This is 1. Okay. Now let us see if you cast let us also see the class of this before I move forward. Class LR underscore DF dollar target 2 factor. Yeah. If I directly cast this column to integer, what will happen? So in factor, what will happen is 0 factor assigns each of the values as levels. 0 will be at level 1. Yeah, 0 is level 1. 1 will be level 2. Now, if you are going to convert this as integer, so LR underscore DF dollar target 2, and now I am directly converting as integer. From factor, I am directly converting it to integer. DF dollar target 2. Okay. Let us view this data again. This has become 1 and this has become 2. So what happens is when you directly convert a factor to integer, the level values goes into that column. As a result, what will happen? Data corruption. As a result, it will lead to data corruption. So the right way, or there are multiple ways to do it. One of the ways, let us create this target 2 column again. When I run this, I'm again now creating it as a factor from target column. Okay. Now if I want the right values to come here, the way to do it is you first cast it to character. So this is first level casting I'm doing to character, and then cast it to integer. This bracket I ran it. Okay. Yeah. So this syntax is what I have to run. First I'm casting it to character and then casting it to integer. Okay. Now let us view this data. 0 ones. Everything proper. Yeah. So factor, if you have factor capturing integer values or numeric values, do not cast it directly. Cast it as character and then cast it as integer. Otherwise, it will lead to data corruption. Clear?
But if it's a mix of numeric and character,
then it will be character.
Because test ID was mix of both.
Yeah, and it will be character. The problem is only factor to integer or factor to numeric conversion. That's where the problem comes. So it has to be a character and an integer. Either you do this syntax, or there's another syntax which I have given you, which is you can use levels. This syntax which makes use of levels. This is slightly complicated to understand. As such, I myself prefer typically this syntax. Yeah. But if you have a very big data set, then what I would suggest, if you are working with a very big data and you have to do that, then you come to this presentation slide, see this syntax, exactly type it and do the casting. Yeah. So let's try these syntaxes which I have just now showed you. First is casting to. First we'll run str command, see the structure, then we'll do casting to character, custom ID, then we are going to create a target 2 as a factor. We'll directly cast it without character conversion, and then you try with character conversion. Okay, So these are the syntaxes that you have to try now. These are the syntaxes. So we just saw converting variable types and other variable types like simple one as.date, as.numeric. So just type as dot something and you will find out the conversion syntaxes. Now let us see sorting. Again, as I said, don't learn these things syntax. Gradually now you have to move out of syntax. Think applications. Simple application of sorting, real life application like ticketing system. You have gone to airline website and you try to book a ticket, and they typically provide you the departure time, arrival time, price, right? Now by default sorting is done by price, but quite often it is not necessary that price is important for you. Quite often reaching for a meeting at a particular destination, that is more important, and for that if you want to have to take a ticket which is high cost is also okay. So in that case you would like to sort things by departure time or arrival time, right? Again, when you do these ticketing things, you would have seen on the side there is a filtering, 0 stop, 1 stop, 2 stop, and many times you would not like those 1 stop and 2 stop flights to come because you want to go directly. So that is application of filtering. And now here the point I'm trying to make is the parameters are dynamic. You're selecting an option and those parameters are going dynamically. So that's why when I wrote that which clause, I said okay, cust id equal to where, and where equal to cust id or where equal to something. I used those syntaxes, and there dynamic programming and all those elements comes into play. Yeah, but here let's focus on the sorting now. Sorting has got its own application. I want to find uh, top 10 employees who are highly paid. I've got an entire data frame where salary information is there. Top 10, I just sort it. I first sort it and then take 1:10 and get the top 10, right? So these are the practical application. The syntax is, because sorting happens for rows, the syntax has to come in the row position. And most of the programming language, sort is called by order. Sort is represented by order, right? So here also we have similar syntax where we will use order function, and this order function has to come in the row position. See, comma is there and after comma there is nothing, so that sort element is coming in the row position. Again note LRDF, attach. Because I have attached, I am able to refer the columns directly. If I do not do attach, the syntax would have been order LRDF $H LRDF $holding period. So let us do the sorting, which is ascending sort for ordered by age and holding period. DF sorted LR underscore DF, and the syntax will come in row position, order, age, comma, holding period. If I run this syntax, it will give me error. This syntax will give me error saying object age not found. Either I change the syntax to dollar like this, or I say attach. There. The moment I attach it and then I run the syntax, it worked. Okay. So if I do view, now if I do view of this data set, age 21, and then as you scroll you will see age 22, 23, 24 and so forth, 27, and if I scroll completely down, the highest age 55. This syntax is a multi-level sort. The first sorting is done on age. The second sorting is on holding period. Now, how does multi-level sort works? The first sorting is on age. Now, within age, I have got customers who have got different holding periods. So within age 21, first get me the lowest holding period. So here within age, for what I'll do, I'll use this interface and do filter, and I'll say 21. I want 21 only. Okay, 21 to 21. So this, my entire data is filtered now. Now if I see holding period, say 0, 1, 2, 3, all this record is sorted by holding period also within age. Yeah. So that is this is a syntax of a multi-level sort. Yeah.
When they are giving two parameters and it's a
Yes.
and if you were given only age,
If I would have just said age, it would have a single only sorted by age. Yeah. Even Excel provides you multi-level sort. Now here by default the sorting is happening ascending. In case I want descending sort, I'll just do a descending sort also. Say I want descending sort by age and ascending by holding period. I just prefix the column which you want descending sort by the minus sign. So it will become descending. So here I put minus age holding period, and let me rename this sorted. Let me call as descend sort. Okay. So here minus age comma holding period. In this case, sort, and I now do view. Age 55 has come up, but holding period is still starting with 0 because a holding period was still ascending sort. So within 55, first 0, 1, 2, 3, and then 54 will have holding period 0, 1, 2, 3, 53 holding period 0, 1, 2, 3, and so forth. So that is called multi-level, and now here we have used also the descending option. Yeah.
if you want to apply that in descending order, the holding period is where you will put a negative.
So if I just put a minus sign here also, it will become both descending. Yeah. So, and once my work is done, after attach, what you should do? Detach. Once my objective of attach is completed, I have to detach it. So I say detach. So this is the syntax. So just try these 5 syntaxes which I have highlighted.
This sorting only work on factors?
No, it is not necessary that sorting will work only on factors. Sorting can work on numeric columns also. Age was.
I'm trying to, what I try to do is I'm trying to sort by gender.
Yeah.
Then so पहले F आता है फिर M आता है.
Hmm.
Then I put a minus sign in front of this thing.
Yeah.
Then it's showing me an error. Descending to.
No, sort will happen both ascending and descending sort will happen for even character columns. Okay, so now let's move to the next thing, which is aggregation. Many times what we want to have is how we can see data in an aggregated format. Yeah, simply because we want to know the distribution of frequency, distribution of the categorical variables, and when it comes to continuous variable, we typically see the distribution which is called percentile distribution. For now, let's see categorical variables, and to get a frequency we use the function table. So I've already detached it. I want distribution of say gender. I'll simply say table LRDF dollar gender, or I want distribution of occupation. Frequency distribution syntax should only be run for categorical variable, not for numeric variables. Basically variable like balance, where there are number of values, number of distinct values, because the balance of each customer can differ at paise level. Okay, so you should not run frequency distribution for numeric columns. If you run it, a huge output you will get on a screen. Yeah,
Number of trade transactions.
again it's a continuous variable. Okay, ideally you should not be running it. You, on those type of numeric columns, you should ideally be running a percentile distribution. Yeah, so not balance, occupation. So we'll run this. Now here what we are getting is the absolute number of records in each category. So when I see this, it says in this data, assume this is data of entire customer base, then it will say there are 5,525 females, 14,279 males, and others are 196. Okay. Still interpretation is not very clear because the numbers are in absolute terms. To make the interpretation very clear, what you require is typically proportions. So the interpretation would be more clear if this data would have been like this. Here I get total equal to sum. Okay. So when I see these numbers like this, I can say, okay, 28% of my customers are female, 71% of my customers are male. That becomes much more intelligent interpretation of these numbers. Yeah. However, at times you require even the absolute numbers. For example, if I want to send a campaign, I want to know how many customers I can target. In that case, the proportion is not important, the absolute number is important. Yeah. This proportion that I have computed manually in Excel, you have to find an equivalent syntax in R by which you can get the proportion directly in using R syntax. That is your homework. Okay. At times, the information which you see in one single column, single variable may not be sufficient. You may require a two-dimensional view to make the interpretation. So here that is called cross-tab. When you see two categorical variables together, it is called a cross-tab. Okay, that's a technical term, cross-tabulation. So here to do cross-tab, the syntax is again same table, but only thing is you have to pass two parameters. So here if I want to do a cross-tab between gender and occupation, I'll say gender, comma, okay, probably what I'll do is I'll put this in a different order. I'll put this first. Yeah, I get this output. Now when you have this data, data text to columns, this is missing category. Okay, so this is a cross tab. Yeah, I could have done this cross tab with another variable, say age bucket. Let me do with age bucket and show some insight to you. Okay, I'm doing with age bucket. Intentionally I'm doing it, so show some insight, and let me override this. I'm deleting it. Data text to columns. Okay, this is the data. This data can be now interpreted in multiple ways. How? First, let's do total. If I do sum, these values are row total. All of you agree? Yeah? If I do sum like this, these values are column total. Yeah? So when I see column total, it's 5,525 females. So I can say this as call total, and can I name this as row total? This simple cross tab, there are multiple ways of now seeing this data point. We'll see that how. Now as I said, while doing syntax, main important is all interpretations. So now I'm going into some interpretations. Okay. If I do this as a ratio of what I should be constanting, I'll make J as constant. Okay. So J is now constant. And this I convert to percentages. This also I convert to percentage. What does these number 44, 55 and 0.7 indicate, represent?
Percentage of female under 25.
Percentage of female in 25, less than 25 is 44 percentage. Percentage of male in less than 25 age bucket is 55. So this I can say is row proportions. These are row proportions because I'm taking a row as 100 and then seeing how is the gender distributed in a given age bucket. So this is called row proportion technically. Yeah. So here let me label this as row proportions. And this we can do for the entire table now. Done. I could have done this entire thing calculation like this also. I take this table here and paste it here. Okay. And now I take this as a ratio of this F4. This time around I'll make 12 as constant, right? So this, I can paste this formula across, convert to percentage. What is this number now? 14.2. What does this represent? 14.2. 14.2 percentage of the total females is in the less than 25. So this is called as column proportions. Okay. And finally, there's another proportion that we can compute. if this is a ratio of what these cells, this value show that 3.9, this is the percentage of overall. So this is basically overall proportion. So when you do a cross tab, the each cell value can be seen in three different ways. One is a row proportion, second is a col proportion, and third is a overall proportion. That is the first point. Yeah. This entire output which I have done, but in a nice, much more nice format, you can get easily in R. You have to just find that function. I know the function. You have to find it in R and do that. That is homework. Now let me come to one important insight that you can drive. Assume this data is a complete data of your employee base. Assume these are not customers. For the time being, let's assume this is the data of my employee base. If I simply see this data separately, then I would have said, if I just see from a gender point of view, I would have said 27.6% of my employees are female, 71.4% are male, and 1.0 is others, where we don't know the information. Okay. But if I see the same information from a different point of view, and now if I focus here in this cell, what inference you can drive?
Out of which more than 25, less than 25 are 44%.
In less than 25 age bucket, I've got 44% females, 55% males, which means as an organization, probably initially there were few females joining. As a result, my overall organization wide distribution is 27% female and 72% male. But if I just focus on the youth and the recent hiring, the youth and the recent hiring shows that I have got more or less 45-55, more or less 50-50 male and female joining the organization. So sometimes some perspective which you see in a single dimension gets lost, and that perspective can come into play if you see things in a two dimension. Okay, so cross tabulation is important from that point of view. Okay, so this is what a cross tab is. Writing a syntax, as I said, again is not important. Getting syntaxes are very easy. Interpreting the output, seeing this row proportions, column proportions, overall proportions, do we do that practically? Yes, we very much do it. Okay. In R, there is a syntax by which you can easily get this output in one line syntax, and that is your homework. Finding out the package through which you can get this output in one line syntax. Okay. So just try these two syntaxes. Okay. Sorry. Yeah, all these things are noted. I already have homework PDF. I'll upload. Yeah, I'll do that. Just try these two syntaxes, but you got the point of row proportion, column proportion, overall proportion. Yeah. And typically when we do diagnostic reporting, when we do diagnostic analysis, we go through these many of these cross tabulation. In industry, when we do analysis, before we do analysis, lots of diagnostic analysis is done, and you may end up doing some 200, 300, 500 such cross tabulations. And the way cross tabulations are done, not just for categorical variables, cross tabulations are also done for continuous variable. Only thing is the continuous variables are first slabbed. The continuous variables are first bucketed. In this example, when we did age versus gender, age is actually a continuous variable, but I already had one bucketed variable of age. Yeah. So typically when you do this cross tabulation for diagnostic reporting, you convert many of these continuous variables into slabbed variables, and then you do cross tab of a particular slab with respect to other dimension. For example, uh, if you do a, say, telecom, and you are having voice usage as a information, voice usage, how much minutes of voice has been used per month, and then there is a column available which is gender, age. Now age versus voice usage, if you want to analyze, either one thing that you can do is at each age level you come to compute what is the average voice usage. But in that case you will have many age buckets, 18, 19, 20, 21, 22 and so forth, right? And if you do mean, mean will just give only one indicator. Mean does not give you distribution. So the other way what you can do is you can say age I'll slab, voice usage I'll create buckets. I'll create some 4 or 5 buckets of voice usage saying low voice usage, medium voice usage, high voice usage, very high voice usage and so forth. I'll create some 4 or 5 buckets. Similarly age I'll create 4 or 5, youths, middle aged, old age and so forth. And then do a cross tab. And then see in that cross tab where I get very high average voice usage. So this is the way typically diagnostic analysis is done. So cross tabulation is one of the reporting most often used. Yeah. There are other couple of other syntaxes also available to do the same cross tab. Will not run these things with. Now when I use the with clause, what I'm saying is the columns that I'm going to refer in the function. So the moment I say with LRDF and then I use this function table, what it says is this age bucket is part of LRDF. So I don't have to now keep prefixing it. So this is another way of doing attach. And this is a temporary attach. Basically it's quick thing. So with LRDF table, I again do the cross tab. This output, when you do this output is actually a output of type table, class of that is table. Here I'm just showing that I can do casting and I'm converting that table into a data frame. Yeah. Now comes aggregation. Sometimes you don't want that aggregation which is shown in a cross tab format. You want the aggregation output in a tabular format. Okay. So here you can use a package which is called plier, and using the plier package you can write some syntax and get the aggregation. My preference is typically to use SQL because I'm slightly more conversant with SQL. So I'll first show you this syntax with SQL so that people who are aware of SQL, they will easily understand, and SQL syntax is slightly more user friendly because it's more English kind of a syntax. Okay, so this output which we are getting, we'll try and get with the SQL syntax. SAS, the reason why I'm slightly focusing on SQL, SAS has its own set of commands, but SAS, many people who started using SAS are people who come from SQL background. So SAS provided a function saying proc SQL. Once you type proc SQL and then you write syntax, you can write a SQL syntax. Okay. Similarly, Hadoop. Hadoop has got its own HDFS, MapReduce, and all of those things. Many of these things that you do in Hadoop, typically you have to do Java programming. Okay. But there is a component called Hive. Hive was actually developed by Facebook. Facebook was maintaining all data using Oracle database. And they had all of these things, all the data being stored in their Oracle database. And they gradually wanted to move to this Hadoop environment because it's more scalable. So they developed something called Hive. In Hive, you can write SQL syntaxes, and that SQL syntaxes then gets converted to some Java kind of a programming automatically in the background, and that interacts with the HDFS framework of Hadoop, and you get the output. So the point I'm trying to drive is this SQL thing is very much used in industry. Many people who come from a database background. So naturally, the tool makers, the people who make these programming tools available to you, they are also trying to see how they can make it easy for people with that background to use it. Okay. So in R, you have a package called SQLDF. The package is SQLDF. If it is not installed with you, then you have to run this command install.packages small case. This syntax you have to run. Let me check whether the package is already installed. In my machine it is already installed. If it is already installed, then don't run install.packages command again. Let us understand the basic syntax structure of SQL programming. In SQL programming, there are certain important parameters and clauses. First is select. It's a keyword. Select says what you would like to select. Now you would like to select, but from where? So you have to say from. Okay. If you want certain filtering to happen, in R we use the which clause, but in SQL that is, and typically in many other programming, it is where clause. If you want to do aggregation, you have to say group by. If you want to order, then there is a order by clause. And just in case, after you have grouped the data and you want to remove certain aggregations which are below a certain threshold or above a certain threshold, then you have another clause which is having. Having clause works on, having is like very much like a where, but only thing is having clause works on a aggregated number and where works on the actual data from where you are first picking out. Okay. So here in this output, I want to aggregate things by age bucket and gender. These are called dimensions. These are called dimensions. Anything by which you can aggregate is called dimension. Important dimensions in business are product, geography, time, channel, customer segment. Okay. Now customer segment can be age, can become a segment, gender can be a segment, marital status can become a segment. So these are certain important dimensions. Product, channel, time, product, channel, time, geography, customer segment. Yeah. So here I want to select gender. So my SQL query would look like this. Select gender. This is a dimension. And I want aggregation to happen. So I want to have how many customers are male, how many are female, and so forth. My query will then become, when you're doing counting, the function, aggregation function is count. I would like to know what is the total balance maintained by male customers, total balance maintained by female customers. So that is aggregation, right? So balance you cannot count, balance you have to sum. So the aggregation function is sum. So in this case I'll have to put balance. Okay. From which table? That is LRDF. In our case it is LRDF data frame. I don't want data which is pertaining to gender equal to O. I want male and female only. So I will say where gender not equal to O. Because I am aggregating things by gender, or group by what? Gender. Grouping is to be done. Information values have to be grouped by gender. I don't want having clause, so I can skip it. I don't want to use order by clause, I can skip it. So this becomes your syntax. Okay. Only thing is, now to run this syntax, you have to embed this syntax in a SQLDF function. Otherwise, this, without embedding it in SQLDF, this becomes a normal R syntax. To tell R that I am now running a SQL syntax, you have to embed it in. Now you have to note that I've used double quote here. But the moment this double quote comes, end of syntax. So what I have to replace is this time like this. Or if I want to continue using double quote there, so I make this as single quote and this as double quote. This is basically a programming again rules, that if there is a double, you are opening a string by a double quote, you have to close it by double quote, but within that again a double quote has to come. You cannot use double quote, then you have to use single quote. If you are opening a string with a single quote and closing with single quote, in between you have to use single quote, you cannot.
It's not like brackets.
Okay, so you have to use a double quote. So this becomes my syntax. So let us run this syntax. So loading required this package and I got my output. There are some warnings, but I will ignore the warnings, and this is the output. Yeah. If I would have done, let me see if with double quotes this warning goes off. I don't know, but let me try. Yeah, here's my syntax. Yeah, probably it wants a string to be in double quotes and inside it should be in single quote. So the warning, that warning has gone off. Yeah. So this is SQL syntax. Now here when I got count 1, I did not give us a name. Again, in SQL you can give alias. So I could have said AS CNT, which is count, and this sum I'll say AS some bal. I give this alias. Now in this case, when I run this syntax, you'll see alias coming up. Yeah. So this is basically aggregation using SQL DF. Okay. I hope package is installed for all of you and you can now try that.